So welcome everybody to this latest video on 162 Maths, and in this video we're going over a quick topic test with a collection of some GCSE exam style questions on properties of polygons at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started working through this test, there is no indication about whether these questions are calculator or non-calculator. So what we'll do is we'll just assume it's non-calculator, making sure that we do show our full working out. Now, obviously, if the questions do appear on the calculator paper, it should be therefore relatively easy to work out. So let's have a look at question 1. So question 1 says work out the value of x. And the important thing to note is that this diagram is not drawn accurately, but you can assume that it's still going to be a quadrilateral. So for this, what we need to do is add up all the angles, and we know that angles inside a quadrilateral add up to 360. So here we've got x plus 120 plus 50 plus 30 equal 360. So if we add up these three numbers, we get x plus 200 equals 360. So x equals 360 minus 200, which gives us an answer of 160 degrees. Now it then says give a reason for your answer. Well, the total sum of angles inside a quadrilateral add up to 360 degrees. Let me just write that 3 a little bit properly, and there we go. Now the next one then says tick the correct statement. So the ones we need to tick here, it says that a rhombus has equal sides and 2 equal angles. That is going to be true. It then says that a rectangle is a type of parallelogram, and that is true. And it then says a parallelogram is a type of rectangle. Now that there is incorrect. So a rectangle can be a parallelogram because the definition of a parallelogram is that you've got two sets of parallel sides, which is true in a rectangle. You've got two sides of equal length, and that's true as well. And the co-interior or supplementary, and you've got two sets of co-interior or supplementary angles, which again in a rectangle is true. And that there is a definition of a parallelogram. However, moving on to 2C, a parallelogram is a type of rectangle. Well, the definition of a rectangle is that you've got two sets of parallel sides, which is true in a parallelogram. You've got two sides that are two pairs of equal lengths. That's true as well. But the interior angles of a rectangle are all 90 degrees, which in a parallelogram is not true. So that one there is false. It then says opposite angles in a parallelogram add up to 180. Now this one can be open to interpretation, but the definitions of an opposite angle are this angle here and this angle here. So those two angles are not going to add up to 180, so that one there is false. Now again, it really depends. There might be some argument to say that this angle here is also opposite this angle here, which do add up to 180 because they are supplementary or co-interior. However, those two angles are defined as being co-interior or supplementary, not opposite angles. Question 3 then says give the mathematical name of this type of triangle. So you need to write isosceles. And for question 4, it says that the formula to find one exterior angle of a regular polygon is the exterior angle equals 360 divided by n, where n is the number of sides of the regular polygon. Find the exterior angle of a regular polygon with 20 sides. So that's when n equals 20. So if I then do 360 divided by 20, which if I write as a fraction might make it a little bit easier for me to work out. So that's going to be 18. And so the final answer should have is 18 degrees. Question 5 then says write down the mathematical name of this shape, and it's got 5 sides, so it is going to be a pentagon. There we go. And then the question 5b then says work out the size of one interior angle of a regular decagon. Now a decagon has got 10 sides. So to work out one interior angle, what I need to do is do 180 multiplied by the number of sides, which is 10. Always take away 2, because what we've done there is worked out how many, this is to work out how many triangles there are, and each triangle is 180. So that's going to be 180 multiplied by 8, and that gives me an answer of 1440, and then we need to divide that number by 10 and we get 144. So that's one method of doing it. Another alternative you could do is, well, you've got 360 because that's exterior angles, and if we divide that by the number of sides, which is 10, that gives me 36. So this is the exterior angle of a decagon. And then if I want to work out the interior angle, that's going to be 180 minus 36, which gives me 144 as well. So any of those two methods would be absolutely fine.